Okay, good afternoon, everyone. Good afternoon to our fellow mechanical engineers. We would like to, first of all, thank Philippine Society of Mechanical Engineers, 69 Chapter Singapore, for allowing us to be part of this webinar, especially our President, Engineer Roselier Torres, and all his officers for involving Deluge to do the presentation for the clean glass agent suppression system. And also, we'd like to thank all those members of the PIFPO, Philippine Integrated Organization for Fire Protection Organization in Manila. And same with the Philippine Mechanical Design and Fabrication in Manila. And the fire protection specialists, my fellow members there in Middle East. So we would like to thank you for this webinar. And without any further ado, I would like to present to you our technical speakers for today's event. We have Ms. View and Mr. Jacob. They are my colleague on the fire protection product department. I am in the project department. So Mr. Jacob and View have conducted trainings for consultants such as Arup, Surbana Jurong, and government agencies like LTA or Land Transportation Authority in Singapore. They have also been invited for talks in UL events in Vietnam and Indonesia. And few of the major projects where they were involved are in Yoma Landmark, MINDEF projects, MOH projects, and the project where I'm involved to now is the Changi Airport T5. They are well experienced and have gained a lot of years in this business. So without any further ado, let's welcome Ms. View and Mr. Jacob.
Thank you. So first of all, I would like to thank PSME Singapore chapter, the Vice President, Mr. Richard, the Technical Chairman, Mr. Forente, and of course, Mr. James for organizing this event and inviting us to be here today. My name is View. I am the Product Manager for Deluge Supply Chain, and it is my pleasure to be speaking to all of you here. We'll be conducting this presentation in two parts, starting with the introduction of the gas suppression system by me, and the standard design consideration for the system by my colleague, Mr. Jacob. Along the webinar, if you have any questions, please feel free to type your questions to Ms. Erika Tian, our admin, in the chat function below, and we will try our best to answer them all at the end of this webinar. So before we go into an in-depth training, let me give you all some ideas of who we are. Deluge is incorporated in 1983. With more than 3 decades of valuable experience, Deluge is now one of the largest and most comprehensive fire protection solution provider in Singapore. We are 100% local company with L6 grading. Under BCA, we design, engineering, comprehensive off-site fabrication, and installation of fire protection systems. We have strong portfolio for water, gas, and foam-based suppression system used in combination with fire detection systems. Appointed by BCA in 2011, Deluge was the first BCA authorized training and test center. Not only that, we also have 3-story building with over 1,850 square meters workshop space dedicated to prefabricating of pipe works. And we do not stop there. Deluge has evolved from a single offering of fire protection to a one-stop M&E solution provider. Deluge E&C is one of our subsidiaries which bundles plumbing and sanitary and ACMV as part of a suite of services. Through that, Deluge Fire is able to secure large projects and realize synergies and cost saving for site installation. We provide a full range of engineering fire protection services, including water, dry chemical, and our own gas suppression system, which we are here to learn about, as well as foam-based suppression system and other firefighting equipment. Not to forget, fire detection system. So yes, we have got you covered for all of your fixed fire protection needs. We use proven, reputable brands which adhere to stringent environmental standards to ensure our clients receive reliable, high-quality, environmentally friendly fire protection solutions. Focusing to provide our customers as a one-stop service shop, our warehouse of over 210,000 square feet has the largest inventory in excess of $1 million worth of stock. Our in-house Deluge fleet of lorries, service vans, and aerial platforms can ensure timely and efficient deployment of manpower, materials, and equipment to sites. Apart from that, we enjoy the distinction of being the first fire protection company in Singapore to offer a one-stop design and build engineering solution. With our prefabricated fire pipe solutions, we are the first fire protection company to invest and build our own factory at the Johor. Our 8,000 square meters factory can produce up to 400 tons of prefabricated steel pipes per month to serve ongoing projects in Singapore and across the region. Perfectly made to order and the ability to quickly produce and assemble on our factory space allow us to quickly answer to customers' query, produce and deliver for fast-track projects. Prefabrication is the Deluge difference as it enables high-quality production and speedy delivery. This is the main reasons why Deluge has decided to produce our own product as well. So apart from prefabricated pipe, Deluge also offers a pre-assembled skid-based system, control valve and flow switches, being installed in many projects such as LNG plant, our Deluge valve house here, and our valve skids. To wrap up the story, Deluge has various in-house support groups and more than 600 relic workers to work on our projects. We have many subsidiaries who work hand in hand with us to allow our customers to enjoy greater convenience and ease of cooperation from our full spectrum, one-stop service solution. As I mentioned earlier, Deluge has a BCA L6 grading for fire protection, which enables us to participate in tenders of any value in Singapore. Deluge is ISO certified and BitSafe Star. Our production processes are audited regularly and are certified to ISO 9001, 14001, and other standards. Deluge has also won the prestigious Enterprise 50 Award for 3 years in a row. The award recognizes the best SMEs in Singapore for excellence in entrepreneurship. And even to some of the major projects, such as Changi General Hospital and Hampton. Award of Best Practice as well. We have served a diverse range of clients from the various industries, local and abroad. We have quite a number of projects references in all sectors, including both onshore and offshore one. Ranging from power plant sector, aviation, marine, oil and gas, hospital, commercial building and institution, government and infrastructure, and even waterfront projects. The major projects we are working on in Singapore include JTC Defu, Cities, Thomson Line MRT, Mandai Depot, MINDEF Military Project, Kim Chuan, National Skin Center, Changi Naval Base, Changi Water Reclamation Plant, and many others more. Deluge also has expanded overseas and set up offices across the region, including Vietnam, Belgium, Indonesia, Myanmar, Thailand office, which at the moment is handling the new Thai Parliament project, and Malaysia office, where we target high value added segments such as aviation and pharmaceuticals. So serving our customers with quality, reliability, and value, making Deluge preferred by many leading brands. And we utterly hope to be the preferred partner to all of you here as well. So I hope you all get the clear pictures of our company profile now. So let's move on to our training. Let me remind you all again that along with this webinar, if you have any question, please feel free to type it and send to Miss Erica Tien. So at the end of the webinar or in our Q&A session, we'll be answering to all of your questions. Okay. So as you all might have known that Deluge has been in fire protection industry for more than 35 years, right? With our mission to continue being the preferred partners of our clients and the core values mentioned here, Deluge has taken another big step to serve and ensure our clients with highest quality products of our own name. And before we go into hear about the next session here, let us see through how I'm gonna explain or walk through to the reasons why or when do we need to use clean agent suppression system. For those who just joined in this webinar, please feel free to write your questions along with this webinar to Miss Erica Tien directly to our admin, and at the end of the webinar, we will try our best to answer every one of your questions. Okay. Okay. Let's begin the first part of the training. So what is a better way to show you the comparison than to show you the real situation happen? This is a picture of an actual office with electrical cabinet that happened to be caught on fire. This is if this office were to use clean agent suppression system, the detector will quickly detect the smoke or fire before it gets too big and discharge the gas to cover the area within 10 seconds. However, as compared to a sprinkler system, in order for the bulb to break, the fire has to be quite big for the heat to break the bulbs. And this is what happened when sprinklers activated. As you can see from the picture, apart from damage from fire, this office also faces electrical equipment and other collateral damages as well. With that said, any water used indoors, meaning you are left with a moisture problem that needs to be addressed. Sprinkler system water damage can include wet drywall, carpeting, and other building materials. Those damage also follows by the intangible costs, such as the loss of time as well. So how can we prevent that from happening? Here's the answer. Hidden in the QR code or this short URL in front of you. For those who view this webinar with your laptop, may I ask you all to take your phone out and quickly scan this for me. For those with your phone, you can type bit.ly/delugeca into your web browser and you will find the same material as well. Okay. While you all are scanning the QR code, let me tell you a little bit about a fun fact here. Many of our customers still have a misunderstanding about clean agent. They would ask for Novak 1230 or FM 200 clean agent, and we usually say that no one has it. Why? So This is the pictures captured from NFPA 2001, right? Showing all types of clean agents. As you can see, it does not mention Novak 1230 or FM200. Why? Because the real name, the real agent designation for Novak 1230 is FK5112, and for FM200 is HFC227EA. Right. So what are those Novak name and FM200 name? It's, for example, it's just the trade names, right, owned by certain brands. But the example of this is like you calling a sticky tape or scotch tape. So actually you're supposed to call it a sticky tape, but for some reason most people call scotch tape, right? But actually all brands are using the same chemistry compound, meaning being Novak 1230 or other names that you might have found in the market, they are all FK5112 with the same chemical compound, right? So it's the same as water, whether the brand is Yvonne, Montfleur, or Fiji, they are all water, which is H2O. So these two gases, FK5112 and HFC227EA, are using the method of restraint for combustion chain reactions or cooling the heat from the fire, similar to water. Whereas other clean agent listed here, such as IG100, also known as NN100 by Nomi Bosai, IG541, also known as Energen as their trade name, and IG55, also known as argonite, using the oxygen dilution, which can be harmful to human. So back to the answer to the previous question, or what is in your hand or the materials in your phone right now is Deluge is now offering our Deluge clean agent suppression system, namely Deluge 227 and Deluge 5112. So Deluge 227 is a system using HFC227EA or equivalent to FM200 to suppress the fire. Its characteristics are being colorless, odorless, safe for people, non-corrosive, and the answer to the previous question, free of residue and electrically non-conductive. The system is low pressure. However, we have both 360 psi and 500 psi for further distant option. Next is our Deluge 5112, which in turn uses FK5112 or equivalent to Novak 1230. The two gases are similar, and the only difference between the two is the global warming potential. For Deluge 5112, we have system for 500 psi. As I mentioned, both gases have similar characteristics. The only difference is the GWP or global warming potential, as highlighted in red. Both clean agents are made from the same raw material. However, to manufacture FK5112, it generally requires more raw material and is harder to produce, hence the higher cost per pound as compared to HFC227EA. HFC227EA is also known to be used as the propellant for asthma or Ventolin inhalers. A majority of military projects still insist on using HFC227EA. But in terms of firefighting, the release of HFC within the atmosphere contributes to a very small percentage and amount compared to other industries, such as the air conditioning industries. So, however, if talking about clean gas suppressions, you might have the question, why not in a gas systems? So here, let me tell you why. This is the table showing typical agent required for the same volume of enclosure, 200 square meters. As you can see in the red circle, IG systems require more agent and also numbers of cylinders. It requires more FK5112 than HFC227EA and more HFC227EA compared to previous Helen systems. For easier comparison, you can see the number of the cylinders used in this case, up to 5 cylinders compared to Deluge 227 and Deluge 5112 system, which only use 1 cylinder. And of course, more cylinders will incur the mechanical component cost along with it, such as valve, flexible hose, or check valve. Using less agent required, meaning less cylinder and spaces to store and in turn leave our client more rental avenue and also save the maintenance costs as well. This additional hardware of IG systems require more maintenance compared to Deluge 227 and 5112 systems. So the upfront cost may be lower in some cases, but the long-term cost will be higher. Not to mention that IG system is also dangerous where there are cases that the cylinders explode because of the high working pressure. The general working pressure of IG system are 8 to 12 times higher than low pressure system. Low pressure system generally do not require a PRD or pressure relief dampers. However, for high pressure systems, this is a requirement. Another key point to take note in low pressure system is that there is no potential damage to hard disk drive. So for those data center projects which will require the decibels to be less than 120 decibels, low working pressure system will be a suitable solution for it, where high working pressures can create noise more than 130 decibels and hence potential risk to the hard disk. Sequence of activations works as in two-zone systems. In case of fire, one of the two detectors senses the fire. Alarm will immediately ring along the activation of the evacuate sign and stop light. After the confirmation of an actual fire condition, the clean agent will be released immediately after the present time of 30 seconds delay from the second alarm activation. The horn will sound along with the activation of the gas discharge sign plus auxiliary connections to ASU tripping, fire brigade alert, and other telecommunication devices, which all of this Mr. Jacob, my colleagues, will explain in depth further in the latter part of this webinar. Now that we have learned about the system, we need to know how we can ensure the quality of the products, right? So let me talk a little bit about our approval to ensure you of the system. The Deluge system is UL listed under the file number EX28145 in the directory for total flooding protection against all Class A, Class B, and Class C fires, which cover the range of design, installation, operation, and maintenance as well. The clean agents that we use in our system are UL components recognized, FM approved, and United States Environmental Protection Agency SNAP listed. This is the pictures from our fire testing, which we have passed for all classes of fire. So just now we have ensured you with our product quality, but what are the benefits that we can offer you as a manufacturer? How can we help our clients with their costs and with new and improved products? First, Deluge choose to offer 12 different sizes of cylinders ranging from 20 pounds to 1,200 pounds. 12 different sizes of cylinder. Some of you might wonder, why do we offer so many sizes? The reason is to be cost efficient. Imagine if a server room needs 375 pounds of gas. Most of the gas suppression distributor will give you 2 of the 200 pounds cylinders, but we as a manufacturer will give you only one 375 pound cylinders. So in turn will save you from paying for extra mechanical components. However, there are more ways to improve the product. So we did not stop there. Our in-house research and development team has found another solution. Another fact that we found from hearing from the pain point of our clients, we know that one of the major challenges of the fire suppression industry is galvanic corrosion. The standard cylinder in the market is using brass valve with carbon steel cylinder. Both materials are dissimilar materials and will eat into each other, causing the corrosion on the system components and often result to accidental discharge. So our R&D department has developed a way to stop the corrosion by using stainless steel. The corrosion also does not only come from the materials, but also from the chemical reaction of the gases as well. When FK512 comes into contact with water, it will become highly corrosive acid. However, if using stainless steel, there will be a formation of chromium oxide to protect against corrosion. This is a graph to show the comparison of the corrosive potential. And as you can see, the stainless steel at the green arrow here has the least corrosive potential compared to brass and carbon steel. So the carbon steel in the market rely a lot on the thin paint on the cylinder to protect it from rust, whereas the stainless steel does not. Once the paint is gone from doing the maintenance or the scratch on the carbon steel cylinder, the corrosion will start. As for the conclusion, it is recommended to use stainless steel material, especially for the storage of FK5112. With the problem stated, Deluge assemble our own valves and offer 316 ounce as stainless steel as a standard offering. Sizes range from ½ inches to 4 inches, and the method we use in the investment is investment casting, which makes the molding method more smooth. We will also be launching our stainless steel cylinders this year to pair with our stainless steel valve, giving an even better and stronger qualities products. You can be assured that it will be competitively priced and maybe on par with carbon steel cylinders. Every single product we manufacture are carefully cycled and tested for leakage. Our quality control team at our manufacturing plant in Singapore here guarantees only the best product. In order to get UL listed on our valves, every valve have to go through 500 cycles to pass the hydrostatic test. Our nozzle drilling station here in Singapore is approved by UL. Deluge offers 3 different types of materials, namely brass, aluminum, and stainless steel. We will only drill the exact orifice size according to the full calculation that we also provide for our customers in the design process to follow all the standard requirements. All of our cylinders will be tested in hot and cold room to test the material expansion and contraction in extreme temperature. Our system can be used in 0 degrees to 50 degrees Celsius. We also conduct cylinder expansion tests and cylinder burst tests to our cylinders. Cylinders cannot burst at the seams of the welds, and this will be considered as a fail in testing. The cylinders can only burst at the body. Moreover, Deluge cylinders are tested to 1000 psi, which is twice of the system working pressure. Also, under NFPA, after 5 to 10 years, we have to do hydrostatic tests on the cylinders, of which can be done at our in-house facility. Lastly, dealing directly with the manufacturer from within the region, our clients can enjoy the shorter lead time. Stock availability, we keep stock of all sizes of all cylinders in our warehouse at all times. We are able to provide a one-for-one exchange for critical situations in sensitive locations within Singapore. We do full QC testing before every delivery. For both domestic and overseas projects, we carefully prepare and well secure our products before the delivery. Last but not least, we Deluge have our own UL listed filling station here in Singapore, making it fast and reliable to respond to our clients' inquiries within 24 hours. We keep stocks of at least 20 tons of both gases at all times. Lastly, we Deluge manufacture, integrate, and maintain. We carry our own name into this product as we believe in accountability and responsibility. We research and develop our products according to our customers' pain point and support our clients with fast response to their query and constantly find ways to be cost efficient for our clients. And as the difficult timing like this, we can ensure the clients with no interruption or longer lead time for the products. We are prepared to and take it as our priority to work hand in hand and support our partners during this COVID situation. So I have come to the end of the basic understanding of clean gas suppression system. Next will be the standard design consideration of clean gas suppression system given by my colleague, Mr. Jacob Isaac Chen. May I remind you again, if you have any questions, please do type it in the chat and click send it to Ms. Erica Tian, our admin, and we will be answering that in the end of our webinar. Over to you, Jacob.
5112. You have to understand that these are trade names, especially when it comes to FK5112. That is the actual generic name for Novak 1230, which is trademarked by 3M. HFC 227 is the generic name for FM200, which is trademarked by Great Lakes Chemical, or otherwise known as a DuPont. Okay. Let me go forward to the next slide. Oh, another thing to note is that HFC 227 and FK5112 are derived from the same raw material. Okay. Back then, there used to be another clean agent called halon, of which was widely used. That would be considered 2G. Halon would be considered 2G. 3G would be considered basically the third generation would be FM200, which is HFC 227. 4G is FK5112, which is otherwise known as Novak. So the thing about it is that over time, when these new gases come out, you tend to require larger cylinders or more clean agents within the systems. So this is quite apparent over here when it comes to basically the FK512 and the HFC227. Let's go on to the next slide. Okay, obviously, some of the people here, mechanical engineers, we know the difference between the different hazards. Class A would be ordinary combustible materials, wood, paper, cloth, other soft materials. Class B would be heptane, flammable liquids, combustible liquids, petroleum greases, tar oils. Class C, obviously electric fire, energized fire. Class D, which are metal fire. Basically, it could be sodium, potassium, magnesium, titanium. Class K, which is otherwise known as a cooking fire or kitchen fire. This is cooking oils, greases. So one thing to note is that clean agents such as HFC227 and FK512 can be utilized on Class A, B, and C. But when it comes to Class D fire, there could be some sort of chemical reaction. So it's always important to take the MSDS or the SDS, which is the safety data sheet of the material that you are protecting. So when it comes to Class D, clean agents shall not be used. In order for you to put out Class D metal fires, it has to be used with Class D powder. So this has to be used in the suppression system, which is a powder suppression system using Class D powder to put out the fire. Class K, technically, when it comes to HFC227 or FK512, you can use it for Class K kitchen systems or kitchen suppression systems. However, it is not economically viable because it is more expensive. So what we normally use for Class K would be a wet chemical or a clean chemical that actually puts out the oil fire. Let's go to this one. So when it comes to the minimum design concentrations for clean agents, namely FK512 and HFC227, you have to know that there's a difference between the minimum design concentration and the minimum extinguishing concentration. The minimum extinguishing concentration is done by the NFPA 2001 using a cup burner test. Okay, the minimum design concentration is the MEC times a safety factor. So let's say the FK512 MDC shall be 4.7% and HFC227EA is at 7%. So you also have to determine the type of class of fire that you will be fighting. So it's always good to identify what type of room is this. Is this a server room? Is this what basically you're protecting inside the room? Then from there you can utilize the correct design concentration to actually protect the room. So how do you determine the amount of clean agent required for the room? So first you have to have the volume of the room, length, width, and height. I do realize that there are some rooms in very odd shapes, but you would still have to determine the volume of the room. You also have to determine the hazard room ambient temperature. So when it comes to the temperature of the room, it does affect the amount of clean agent required. If the room is hotter, you require less clean agent. If the room is cooler, you technically require more clean agent. Okay? So another factor that is required to actually understand the design procedure would be the atmospheric correction factor. This will be touched on the next slide. So basically, how high is the room that you're protecting, or depending on the geographic location of where you're protecting, it can determine, or it's another factor which can determine the amount of clean agent required. Okay. Usually for offshore projects, you tend to require more clean agents because it's specified, because obviously in oil and gas, they tend to be more worried, so they usually tend to ask for a higher design concentration to protect their their premises. Yeah. So as mentioned, the atmospheric correction factor, as you can see, all the measurements here are in feet. The tallest building in Singapore, which was recently released, is Woolwich Residences, located in Tanjong Pagar. It stands at 290 meters or 950 feet. So most of the projects in Singapore, most of the projects in the world are usually less than 300 meters high, of which there will not be any correction factor involved, unless maybe you're in the Middle East where there's a Burj Khalifa, or much taller buildings, of which you would have to factor in a certain correction because those buildings are much taller, and then it would affect the amount of clean agent required. So this is an extract from NFPA 2001, the latest edition, which is the 2018 edition. This is for, as you can see, HFC 227EA. This is the testing that has been done based on the temperature, and then from there you determine the design concentration factor. Okay, so obviously at the side there you can see it's based on Celsius. Let's see here. Okay, so for the room at 20 degrees Celsius, we can determine that the design factor that should be for HFC 227 is at 7%. Okay, which is at 7%, which is here. 0.5483. So what you do here is, once you have the volume, you multiply by this number here, 0.5483, then you can determine the amount of clean agent required. So let's say hypothetically you have a room of 100 square meters, right? The volume is, sorry, 100 cube meters. You multiply by the correction factor, the design factor, you get 54.83 pounds of gas required. Yeah. So we go to the next one. This is for FK5112. You can see over here at 20 degrees. So 4.7% is actually in between the 4 and 5% over here. So from there we can actually gather that the number is actually 0.68432. So you multiply the volume by 0.68432, then you can actually determine the amount of clean agent required to protect that room based on that 4.7%. Okay. So what do you do when you determine the amount of clean agents that is required to protect the room? You would have to select the correct appropriate cylinder size. So obviously if you require 100 pounds worth of clean agent, you don't use a 600-pound cylinder, you don't use a 560-pound cylinder. It's best for you to use either a 100-pound cylinder, depending on design, or a 150-pound cylinder to actually factor more nitrogen for you to actually push out the clean agent. Yeah. So the next slide. Okay. For halocarbon clean agents, there's a term called NOEL and LOEL. NOEL stands for No Observed Adverse Effect Limit, and LOEL stands for Low Observed Adverse Effects Limits. Basically, this testing has been done on animals, of which to check whether there's any sort of reaction to the body, whether it's through the blood or through breathing. So we have different NOELs, of which most standard specifications would have to adhere to. So FK5112, the NOEL limit is 10%. For HFC 227, the NOEL limit is 9%. So if we remember correctly, that the normal design concentration for FK5112 is at 4.7%, right? And the NOEL limit basically means you cannot exceed this 10%, and for the HFC, the standard design concentration is at 7%, but you cannot exceed 9%. Otherwise, there will be some sort of effect on the body. Okay. So an example would be if, let's say, the room requires 100 pounds of gas of FK5112, right? But because of the design of the room, the odd shape, certain considerations that you must take into consideration. Yeah, you have to factor in. So let's say if it's 100 pounds required, but you decide to offer 200 pounds of clean agent, and if the design concentration is at 4.7, now you're offering double. So how do you determine the NOEL limit, or how do you determine the concentration that you're providing? It's simple. It's 4.7 times 2. So the total limit that you're giving is 9.4%, which is within the NOEL limit. So that means it's safe. So if the room requires 100 pounds, you give 200 pounds, it's still safe, but yes, it's going to cost you more money because it's more gas being used. Okay, so as you can see, the minimum design concentration, there is a difference between the MEC, which is the minimum extinguishing concentration, and the minimum design concentration. As you can see, the minimum design concentration is a factor, it's a safety factor of the MEC. So you can see, usually Novak or FK512, the minimum design concentration factor is 4.7%. So we usually utilize class C. At HFC 227, the minimum design concentration factor is at 7%. Okay, this is tested at 21 degrees Celsius or 70 degrees Fahrenheit. So additionally, what other design factors you would have to take into consideration when designing a system when designing a clean agent suppression system? Unclosable openings and their effects on distribution and concentration. Certain things where let's say if you're protecting a laboratory fume hood, where you know that the opening is constantly open. So how do you protect the volume in there? Usually you would have to add an additional safety factor of 20 to 30% to account for this unclosable opening. Control of acid gases, reignition from heated surfaces. So it's always good to actually understand the room and what you're protecting and how is the room designed. What are the materials for the walls? So from there you can actually factor this in. And obviously the fuel type, configuration, scenarios not fully accounted for extinguishing concentrations, of which you would have to be present to actually find this out. The shape of the room, also not mentioned here, has to be taken into consideration as well. Obviously, like I mentioned to you, different shapes, odd shapes, circular shapes, you would have to take into consideration. Also, the distance of the room, this is very important, the distance of the room from the cylinder to the protected room. The further the distance, usually you require a larger cylinder with more clean agent, because the distance of the pipe would mean that there will be some residue left within the pipe. Number one. Number two, you will need more propellant, which is the nitrogen, for you to actually push the gas from the distance of the cylinder all the way to the protected room. Okay, this would affect your design factor. Certain areas such as trenches. We know that large trench areas, it's quite hard for us to protect. So what we normally do is we design a separate system linked to the same panel, linked to the same conventional panel with a separate pipe network, meaning that the room and the trench will be activated, but it will not be connected by the same pipe network. That way, you require less clean agent, and the extinguishing time meets the 10 seconds as per the NFPA guidelines. Yeah. When it comes to trenches, one more important thing to note is that you cannot separate it as a separate protected environment. If there's a trench within the room plus the trench is considered one area. You cannot split it up. Okay? It cannot be connected to separate systems, basically. That's what I'm saying. Always remember to check the specifications and the room design. So the system operation limits for HFC 227 and FK512, this is quite standard across the board. The system limits are obviously from 0 degrees Celsius to about 50 to 55 degrees Celsius, meaning that the systems can work in quite hot environments, but it's best not to exceed these limits or to have the cylinders stored in direct sunlight. So we actually have had quite a number of big operators that we know in Singapore that actually store these systems in direct sunlight, which is quite shocking. Usually it would be best, it doesn't have to be stored within an air-conditioned room, but it has to be away from direct sunlight and the elements. So obviously when it comes to carbon steel and brass, valve cylinders is more susceptible to the elements, whether it's humidity, whether it's salt water, whether it's in the oil and gas industry. That's why we have come to offer stainless steel 316L valves and stainless steel cylinders. So that way it's able to brave the elements better, longer. So as mentioned previously, the Deluge offers 12 different sizes, ranging from 20 pounds all the way to 1,200 pounds. Please note that each cylinder has different valve sizes and the min and max fill. So like I was mentioning before, if let's say you have 100 pounds of clean agent that you've determined by calculating the volume multiplied by the design factor, you do not use a 250-pound cylinder, because you can see the minimum fill over here is 109 pounds, right? So it's best for you to actually utilize the correct cylinder, which would be the 150 pounds, right? So your fill range is in between the minimum and the max. So FK512 is a little bit different. It's not exactly the same. The min and max fill range, as you can see, for the 1,200 pounds, the max fill range is 1297. If we go back to the HFC, it's 1137. This is based on the density of the actual chemical involved. So when it comes to FK512, you can actually pack more clean agent within the cylinder. Let me see. Okay, the cylinder valve. So the cylinder valves used in our systems are back pressure type valves. The activation of the valve is from the equalization, right, of pressure from the top via a latching solenoid or pneumatic slave. When the pressure on the top of the piston is relieved, the pressure from the cylinder slides to its open position. Basically, this portion will slide up, right? And then the gas will be able to push up from this direction out to the outlet here. So basically, the pressure from here will be relieved and equalized out. This pressure, which is on top of the cylinder here, will be able to push up and then out the outlet here. Okay. As mentioned previously, I think I've been saying this quite often, the valves that we're offering are 316L stainless steel valves. It comes with a burst disc over here. So the burst disc is basically, in case of overpressure, this is a safety release device. So for the smaller cylinders, it's at 900 PSI. For the larger cylinders, it's at 800 PSI. So you have the pressure gauge here, the outlet, right? The top plug. So basically on top here, you would either attach a pneumatic slave or a latching solenoid. The reason why we don't use electric solenoid, because that technically has been phased out. So the new NFPA regulations require you to have a latching solenoid, which basically informs the panel that it has been detached from the cylinder. Yeah. So as you can see here, this is the larger valves, the 4-inch valves. So it's a back pressure valves. Once this has been depressed, the pressure is equalized. This will actually move up and then out the outlet here. Okay. Obviously, the flex hose, please use the appropriate size of flex hose. So if it's a 4-inch valve, don't use a 2.5-inch flexible hose. It's a 4-inch flexible hose. Yeah. So these are some of the pictures of the cylinder valves that we offer, right? From the 1-inch, 1.5, 2.5, 3-inch, and 4-inch. We have it in 304, 316, and 316L, but majority of our standard offering is at 316L stainless steel. So cylinder brackets, of which every cylinder must come with the cylinder bracket, and it goes to the corresponding size. The larger cylinders require a floor strap as well as a body strap. So this would be a body strap, and the floor strap, which would be attached and drilled through the cement, right? This to ensure that the cylinder does not vibrate violently when it comes to discharge, because although it is low pressure, but we're ultimately still dealing with a pressure vessel, which can be quite dangerous as well. So when attaching brackets, you can either attach it directly to the wall, or it can be attached using a C channel, as over here, as you can see. Yeah. Make sure that the pressure gauge when installing a cylinder is facing outwards, right? Sometimes people want to put the pressure gauge when it's not facing, it's facing inwards. That means it's facing in the wall. This will cause a lot of issues when it comes to maintenance. So when designing a system, make sure you determine if the outlet's on the left or on the right. For Deluge systems, the outlet is always on the left of the pressure gauge. So the pressure gauge will be here, the outlet will be here. Then from there, you determine the pipe. So all the pressure gauges offered from us at Deluge come with a pressure gauge card. This is a pressure gauge card here. Okay, it's all included. The reason for the pressure gauge card is to protect from any damage during transportation or maintenance. So basically, it's just a shield that protects the pressure gauge guard. But not to worry, should the pressure gauge guard be faulty, all the system's pressure gauge comes with a Schrader valve. So basically, if the pressure gauge is faulty, you can just unscrew it without any leakages of clean agent, change to a new one, and screw it back on. So this is the 500 PSI with the pressure gauge guard over here, as you can see. So what is the purpose of a releasing circuit disabled switch? A releasing circuit disabled switch is usually, in the Singapore context, which will be on the outside next to the control panel. It comes with a key over here, of which you need to disconnect. So basically, it disconnects the system. So when you do any maintenance for when it comes to the valves, it does not accidentally activate the system and cause a false discharge, which would be quite costly. So every system comes together with a releasing circuit disabled switch. So local manual control. We offer two different types of local manual control. One would be the lever type. The other one would be the plunger type. Okay. So the local lever driven push rod that depresses a Schrader check valve, thereby venting the pressure from the top of the piston in the cylinder valve. This allows the piston to slide upwards and commence cylinder discharge. It mounts on top of a top plug adapter, or usually on top of a latching solenoid. Yeah, all the local manual control heads come with a safety pin. Right, ensure that the safety pin is always there during maintenance, so there is no accidental discharge. So the latching solenoid has been has replaced the electric solenoid. So what a latching solenoid does is that it sends a signal whenever you remove a latching solenoid. It is able to send an error signal to the panel that the latching solenoid has been detached, right? So when testing the latching solenoid, ensure that you disconnect the latching solenoid from the top plug adapter of the valve, because sometimes it can accidentally fire, right? We have certain cases where the latching solenoids have been placed in certain magnetic environments. This sometimes can cause different accidental discharges. So take note of the environment that you're protecting as well. Yeah. So, okay. So the actuator is held in a latch position without power until a signal from the agent release control panel cuts off the permanent magnet. When released, the latching solenoid opens the cylinder valve, allowing the extinguishing medium to discharge from the cylinder into the system. Fast response times allow the clean agent from the system to be released in the event of a fire. Yeah. It is designed with an emergency release local manual control. As mentioned before, the local manual control is to be put on top of the latching solenoid, right? You have to manually force the pin to depress the cylinder valve to release the extinguishing medium when needed. So this is another form of activation for the cylinder, of which if you have more than one cylinder, you can use a piston actuator slave. This would technically save more cost and reduce more power draw from the control panel. So what you do is, it basically features a pneumatically driven piston that depresses a Schrader check valve, thereby venting the pressure, which is the same. So it pneumatically does it instead of electrically using. So for you to activate it, you can either use a flexible hose, right, or copper tubing. It really depends. It is to be connected on top. So piston actuator, one pilot, you can see this is all the master pilot, and these are all the slave cylinders that are to be pneumatically activated. Yeah. There are certain constraints because the more cylinders you have, by the time this activates and by the time the last one activates, there is a time difference. So there is always a limit to the number. You cannot just daisy chain everything on. There has to be a limit because there is a timing issue from when this is released to when this is released. So you always have to take note on this, right? So when it comes to discharge nozzle, I think it was mentioned previously, there are two different types of discharge nozzle, the 180 sidewall and the 360 central. I'm not gonna, I think it was mentioned previously by View that, oh, is this a silent nozzle? You know, is this a silent nozzle? No, I mean, technically our system does not require a silent nozzle because ours is not a high pressure system. If you look at all the silent nozzles being offered in the market, those are for high pressure systems, IG100, IG501, CO2 systems. Those are the ones that require silent nozzles because they're 8 to 12 times higher pressure, of which when discharged, it creates a high pitch. But for our systems being a low pressure system, you don't require a silent nozzle. When we have actually tested this, when it comes to the discharge decibels, it is less than 100 decibels. So it will not disrupt your hard disk drives in data centers or your server racks or anything like that. Okay. So the sidewall nozzle, 180-degree sidewall nozzle, is typically installed adjacent to the center wall of one enclosure. Its discharge path will be across the enclosure. So if the room is this way, in a square shape, it is usually on one side of the room or this side, yeah? The use of two 180 nozzles may be installed at the center of the enclosure. The reason why you want to install two 180 instead of one 360 is that one 180 sidewall nozzle can shoot up to 40 feet, but a 360-degree nozzle can only do 20 feet all around. Okay, so basically you put two sidewall nozzles back to back. This will ensure that when you activate, the amount of coverage is double one 360. Okay, 360-degree nozzle or central nozzle is typically installed at the center of the enclosure. Its discharge path will be across the enclosure, which is all around. So if you put two 180 back to back, you can shoot up to 40 feet this direction. The other nozzle here will be able to shoot 40 feet the direction below. But if it's a 360-degree nozzle over here, right, it's 20 feet in all directions. I've had some inquiries previously in some jobs whereby some of the clients and even the consultants want a 360-degree nozzle to be placed in a server room or a data center. They want the 360 to be put in the center, thinking that there'll be better coverage, you know. But you have to understand that this system is a total flooding system, so it doesn't matter whether you want it to be in the center of the room or at the side of, or a sidewall nozzle at the edge of the room. It will cover the whole premise, so you don't have to worry, because sometimes they think, oh, I want it in the center, so in the center it's able to, it's safer, it looks better, and it's able to cover the whole room. This is untrue. And certain reasons why we do not offer 360-degree nozzles in the center of the room, because obviously during discharge, there is a temperature difference from the cylinder and the room, and this can sometimes cause condensation. So the condensation from the nozzle, sometimes it may drip moisture down into the server racks, or within the data center, thus damaging the equipment. So that's why we offer 180-degree nozzles. So this is the discharge nozzle selection, right? This is determined by the flow rate. The largest nozzles that we offer are the 2-inch nozzles, right? Where the maximum flow rate is 33 pounds per second, right? From the quantity of the HFC 227EA or the FK512 determined earlier, divided by 9 seconds, right? 9 seconds is basically below the 10 seconds that is required under NFPA. This will determine the main pipe flow rate, right? From the table on the right side, find the nominal pipe size that is required, and then this will also determine the nozzle size. For flow rates more than 33 pounds per second, right, you have to determine more nozzles for you to actually cater to this higher flow rate. So as mentioned previously from view, we have 3 different materials of nozzles: aluminum, brass, and stainless steel. So for stainless steel, we usually offer that for offshore oil and gas projects, which they really like a lot. For aluminum, we can only use that for HFC 227EA systems. And for FK412, we can't use aluminum systems, we can only use brass, right? So the nozzle coverage area, as I mentioned to you, I don't know whether you can see my mouse. If you have one nozzle at the side here, it is capable of protecting 40 feet in this direction and 40 feet this direction. Yeah. For a central nozzle, you can only protect 20 feet this direction, 20 feet this direction, right? Oops, sorry. So a back-to-back 180-degree nozzle, you can protect a maximum of 80 feet over here. Yeah, shall be installed with the inlet of the nozzle perpendicular to the ceiling when installing a 180-degree nozzle. The side holes of the pattern are to be parallel with the wall on which the nozzle is being installed. All nozzles are rated for a maximum hazard height of 16 feet or 4.8 meters. If the hazard exceeds 16 feet in height, multiple tiers of nozzle must be used for each 16-foot increment of the height of the enclosure, right? The maximum area coverage per nozzle is 40 feet by 40 feet, otherwise known as 1,600 square feet, yeah? So 1,600 square feet is about 148 square meters. So this is the nozzle elevation. So as mentioned previously, 180-degree, it doesn't matter which type nozzle, the maximum height that you can protect is 16 feet or 4.8 meters. So what do you do if the room is more than 4.8 meters, or if it's twice that height? So, sorry, you would have to have a tier, so 2 different level of nozzles. So this one will be able to protect this portion, and this one will be able to protect this portion. I understand that yes, the gas will actually flow down, but this is all within the NFPA guidelines. You know, certain places they may only just want to put a nozzle on top here because they know, oh, okay, it really doesn't matter because the gas will flow down and protect this area as well. Yeah, but under NFPA guidelines, we have to ensure that it is tiered this way, 1 on each level here. So the flexible hoses, as mentioned, it has to be according to the valve size outlet. Flexible hoses are used to connect to the agent storage container to the manifold and multiple cylinders arrangement. Instead of a flexible hose, can you use a pipe? Yes, you can use a pipe instead of a flexible hose, but most of our systems, we actually provide a flexible hose there for you already. Yeah. It is the recommended assembly configuration is to install a union elbow to the discharge outlet of the cylinder, then install the flexible hose between the union elbow and a check valve, with a check valve connecting to the appropriate fitting in the manifold. So this is a shuttle check valve. The shuttle check valve can be used for main and reserve configuration, whereby there are only 2 cylinders in the manifold. So instead of using 2 different separate check valves, you use a shuttle check valve to actually save cost. Yeah, for main and reserve system only. It is used to, main and reserve system configuration. It contains a shut valve, which closes off the pipe to the empty cylinder main to allow the discharge from the reserve cylinder to flow through the discharge piping. So the reason why you require check valves are required so that there is no backflow into the other cylinders that have been manifolded together. So we have different sizes of check valve: 1 inch, 1.5 inch, 2.5 inch, 3 inch, and 4 inch, right? So the number of check valves are required. How do you determine that? Is usually the number of cylinders within the manifold. So every cylinder within the manifold will require a check valve. To prevent, so over here it says, to prevent the loss of agent in the event that any of the agent storage cylinders are not connected to the manifold at the time of system discharge, to prevent the backflow of agent into other cylinders attached to the manifold. The components constructed are from brass for durability and protection. We are trying to, over here at Deluge, to change all these brass check valves into stainless steel check valve, and we're in the process of R&Ding that. Okay, the check valves must be installed in a vertical position, only which the check disc is on top. If you guys have any questions, please send the questions to Erica Tien, and then we may not be able to answer all the questions because we have a limited amount of time, but we will try to do our best. If you need to contact us, you can always, I think View will provide her email address, and then from there you can actually ask her questions. Okay, moving on. What is the requirement of a pressure supervisory switch? So every system would have to have a pressure supervisory switch, whether it's a normally closed version or normally open version. It can be rated from a 360 psi or the 500 psi system. Okay, it is to monitor the pressure within the cylinder. It is attached to a port marked P on our cylinder valve. So this is to ensure this will send an error signal to the panel should the pressure drop. That is what a pressure supervisory switch does. Okay. So cylinder manifolds, when designing systems, when it comes to odd number of cylinder manifolds, right, it has to be a typical N outlet, which meaning it comes out here. When it comes to odd number systems, right? When it comes to either 3 or 5, you know. When it comes to even number, it is basically like a typical center outlet, which is the tournament style, yeah? This is what we call it. So this one would be this would be the latching solenoid, of which each cylinder would have a pneumatic connected by a flexible hose. Okay, the liquid level indicator. We offer the liquid level indicator for all cylinders above 150 pounds all the way to 1,200 pounds. The reason why we use a liquid level indicator because it's to determine the amount of clean agent within the cylinder. This can be quite troublesome if you have a 1,200 pound cylinder and you don't have a liquid level indicator. Sometimes you would have to manually weigh the cylinder to determine the amount of clean agent inside. I know there are some newer generation from, I think it's called Traco, which uses, what do you call it? Ultrasound. Is that ultrasound? To actually determine the amount of clean agent within the cylinder. That is quite costly. So for our systems, we have actually provided as a standard offering a liquid level indicator for cylinders 150 pounds and above. So the way this liquid level indicator works is via a magnetic float. So when you pull out this portion here, there is a measuring tape. When you feel a tug, once the magnet has hit the top of the surface, you take the measurement from there. We have a booklet with a graph provided for you to determine the amount of the amount of clean agent within the cylinder based on the temperature of the room. Okay. Let's move on to some of the electrical components, like the electrical pull station. So the cylinder valve can be electrically actuated by means of manual control, wired to a UL listed control panel for releasing device service. The releasing panel must be compatible with the Deluge electric solenoids. The configuration can be backed up with a local manual control head mounted on top. So basically, if the manual pull station is malfunctioning, you can always run to the cylinder and pull out the safety pin and depress the local manual control. Main and reserve switch is for you to, it is used for systems that incorporate main and reserve agent storage, right? This is quite standard. When one side has been discharged, you just flip it on to the other side to reserve, right? Then from there, you can remove the main cylinder container and then replace and put it back. As mentioned, shuffle check valve can only be used for a main and reserve setup, right? So if this one's being pushed, this portion will slide to the right and then will be released from here. A board switch, the board switch that we offer is the dead man type, which basically means that you would have to constantly keep your finger attached and it has to be held at the board station for you to pause the countdown of the release for the clean agent. This is a typical design of how we place the cylinders. Most of the cylinders that we place within the room should be at the closest corner towards the door. There are different ways you can actually branch out the system. What I prefer to do when designing a system, when using the flow calculation software, is I prefer to use bull tees. Bull tees meaning that it will branch out into two, instead of using through tees, whereby it goes forward and it cuts out, or branch tee. So this way it's easier for you to actually balance the flow, to actually meet the amount of pressure required and also the timing of the 10 seconds. We will not go too much in depth in the flow calculation because it's quite in depth. So I don't think we have the time to actually go to further discuss the flow calculation. So like as I mentioned, this is based on a bull tee. So it splits in half at 3 and 4. Then it splits in half again at number 6 and number 12. This way, by designing a system this way, you ensure that each nozzle releases the appropriate amount of clean agent. If you were to change it to a through tee method, you would have to try and balance the amount of clean agent coming out at each nozzle. This can be quite this can be really quite tiresome and tedious. So what we always do is we always offer a full tee. So when it comes to maintenance, I think quite a number of people actually want to know when do we need to actually do the maintenance for the cylinders. Obviously, there's a monthly maintenance and there's an annual maintenance. The monthly maintenance will ensure, it's basically a visual inspection of the system to ensure that the pressure gauges are in the operable range, ensuring that nothing has been tampered with or altered, and there's no obstruction to any mechanical devices. This is an extract from the NFPA 2001, showing the guidelines of maintenance. Obviously, each manufacturer has their own maintenance guidelines that you would also have to follow. When it comes to accidental discharge, what usually happens? Do you just send the cylinder back to be refilled? Not That is not always the case because you always have to find out the source of the leak, whether it is a mechanical issue, whether there's a leak through the valve, whether there's a leak through the cylinder. So from the valve or the cylinder, what we have to do is we have to put the cylinder under a hydrostatic test to see whether there's any leakages from there. So from there, we'll determine whether to replace the full cylinder or not. Then we can actually point out any issues there. One of the good reasons why Deluge has been moving towards being a manufacturer is that we understand that there are certain times accountability is very important. So we have met with some government agencies whereby there's an accidental discharge within one of their facilities. So as the owner or the operator, they'll go to the installer and say, look, we need you to pay for this, because your system is faulty. The installer says, no, it's not me. It is the distributor I bought it from. Then the distributor will pass it on and say, look, it's not me. It is actually the manufacturer that has given me a faulty cylinder, a faulty valve. So at the end of the day, the owner actually has quite a lot of it basically goes round and round, and the system does not really get resolved. So Deluge is moving towards more of a manufacturing role as well as an installer and doing servicing. So we take accountability for the systems that we install in our projects here in Singapore. So this is the end of my portion. Any questions, please send it to Erica, and I'll hand it over back to you, View.
Yes, okay, guys, we have a lot of questions coming in. So for some of the questions that I think Mr. Jacob also already answered in his part of presentation, I wouldn't go to that. We have quite a lot and we have not enough time here. So first, we have first question. If the source of fire will be a Class E fires, such as the electrical cable of the compressor inside the enclosure, okay? I think this one, I'll get it, because I think the Class C, the Class E that this audience mentioned is actually meaning the Class C for US fire classes. Okay, as the beginning of Mr. Jacob's slides that we have clarified that different countries using different classes of fire, right, or the short term of classes of fire. So actually, the mention here is electrical cable of the compressor, meaning it's actually Class C that we mentioned, right, Mr. Jacob?
That's correct.
Yeah, so actually we do cover that in. So yes, we can use our system as well. Okay.
I think another question I'm looking here is how to calculate the weight of agent for both Deluge 227 and 5112. I think as mentioned before, from there you actually determine the volume of the room. Then from the volume, you look at the NFPA extract at 4.7% or 7%. Using that design factor, you multiply it by that design factor. Then from there, you will get the amount of clean agent required from that room. Once you get the amount of clean agent required for the room, select the appropriate cylinder size that is able to hold the amount of clean agent there. Yeah.
Okay. So another question is, are you considering same duration of extended protection counting after the depletion of main cylinder when we are using FK5112 or Novak and HFC227EA or FM200 with the same room area? Would you mind getting that, Jacob?
Sorry?
Yeah. So the audience asking whether we consider the same duration or the number of seconds if we comparing between FK5112 and HFC227EA, meaning the discharge time. Yeah.
The discharge time at 10 seconds, is that right?
Yeah.
Yeah, it's correct. It's the same.
Yeah. Okay. So
Okay, then let me see this one. Can we integrate VESDA with clean agent fire suppression system? Yes, you can integrate a VESDA system within a clean agent fire suppression system. If so, what is the minimum time for the VESDA to trigger the release of the clean agent? It can be timed, but the usual timing is about 60 seconds. Let me see. In terms of effectivity, Novak is more efficient than Inogen system, but the overall
sorry, Jacob. Just to add to the previous questions, as Mr. Jacob said, that we can add the Vesta panel interface with the original panel. That's possible, right? But please bear in mind that Vesta system has only one alarm. So if you will need the second Vesta system to be the second activated as a second alarm here. So in that case, please bear in mind the cost of that as well. Okay. Over to you, Jacob. Next question.
Okay, in terms of effectivity, Novak is more efficient than Inogen system, but the overall cost of the system is higher. Do you have a table comparison between the agents that shows protection with equipment? Okay, so basically, I think this person is asking, in terms of the overall cost, what is cheaper, whether it's Novak or Inogen system? What we feel is that yes, Novak may be a higher cost upfront, but a lower cost down the road. Inogen, yes, if let's say it's IG100, it's just extracted from the air. There's no chemical proposition towards it. It is cheaper sometimes, depending at the start, but it costs more over a time span. All right, a lot of systems. The reason why I say it can be cheaper or it can be more expensive, it depends, because when it comes to an Inogen system, look, if we can offer a 1,200 pound cylinder, how many other cylinders, how many IG seamless cylinders do you need to offer? You know, you need to offer a lot more. So if the rooms are much larger, you need racks and racks of IG cylinders, of which will be all connected by a pilot, more mechanical components. If there's an accident, if let's say one cylinder in the center is leaking, you would have to pull out the whole rack. So overall, the cost, we feel that our costing is, or when it comes to clean agents, chemical clean agents, we are very comparable to Inogen systems. Let me see. Every 5 years is the hydrostatic test of the cylinder. Is there a maximum times of cycle wherein the cylinder will undergo the hydro testing? Is there a maximum time? So, based on what we understand, there is no. When we send the cylinders to hydro testing, we actually checked each cylinder and we measure whether there's any warping within the cylinder body, and we also check the integrity of the cylinder. So currently there is no limit when it comes to hydro testing, because we do not go to such high pressure where we try to burst the cylinder. That's different. That's for UL purposes. What we do is to check the integrity of the cylinder only. Okay, another question. Do you have any rule of thumb on how I may immediately estimate the number of cylinders based on the room size only? I think this is through practice. Usually the more rooms that you do, the more rooms that you see, then from there you can actually determine the number of cylinders and the size of the cylinder. This is really based on experience. Let's see. Do you have a service of refilling clean agents? Yes, we do have a refilling station over here in Singapore. It is important to note that your refilling station and your nozzle drill station has to be UL certified. That would mean that not anyone can, you cannot just bring it to a non-listed filling station to fill out your clean agents, because then it will not be certified. That means your system will be null and void. So ensure that your system is being filled at the appropriate manufacturer's authorized UL refilling station. Okay, if the master piston actuator otherwise known if the master latching solenoid malfunction, will the slave piston actuator will not activate. Yes, it will not activate. However, for each, uh, 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 that's why we have the local manual control attached to it. It is cheaper, but yes, what you're saying is correct. Unless we attach each cylinder with a latching solenoid, which will be more costlier, but there is also a limit on the amount of electricity drawn from the control panel. Let me see. What other questions are there? What is the lead time upon order agreement? The lead time that we have is around 4 to 6 weeks. Do you recommend the use of clean agents to museums? Clean agents are meant for museums. You cannot use any water mist or any sprinklers. Clean agents have to be used in museums, right? And I would definitely say low pressure clean agent systems, not high pressure, because if you have actually seen a high pressure discharge, things in the rooms fly, your false ceiling flies, mirrors break, glass break, your windows break because it's very high pressure. So low pressure clean agent systems are recommended for museums. What is the difference between the green cylinder and the red cylinder? Green cylinder is the storage cylinder. The red cylinder, the fire red cylinder, is the ones that we put in the room. So one is basically a storage for us to do the refilling. It's just a picture for you to show. It's just a picture for us to show you.
Okay.
Okay, this is a very important question. The pipe schedule used should be a Schedule 40 pipe. Okay, it can be galvanized or can be a black pipe. Schedule 40 pipe, remember. Okay, I think that is all the questions.
Oh, wait, we have more questions coming this way as well. Please advise if the cylinder liquid level indicator is mandatory to provide as per NFPA 2001, Jacob.
Sorry?
Please advise if the cylinder liquid level indicator is mandatory to provide as per NFPA 2001.
It is not mandatory for you to provide. So like I mentioned to you, like certain other companies do not provide the liquid level indicator. So what they offer is either you have to use your ultrasonic, which is by Coltraco for you to determine, or you have to lift the cylinder up, have a giant weighing scale. This is what it is normally done, and then you place the cylinder on top for you to determine.
Okay, I have a question a lot about the lead time and delivery. So please bear in mind that we do not get the interruptions of the lead time because of the COVID situations. And yes, we do still do the production normally, and we do send it out, okay? So next is a technical question. How do we be able to prevent the false activation, Jacob?
How are we able to prevent the false, depending on what type of false activation? Is it false activation by the detector? False activation by the latching solenoid, whether it's the valve? So I think what is most important is for you to offer a complete UL listed system that has been tested and proven. So certain companies, I'm not going to mention names, they Frankenstein their system. So basically the cylinder is from one company, the valve is another company, the latching solenoid is this company. It has not been tested together, but they put it all together. Yes, it's cheap, but the compatibility has not been tested. So for our systems, you have to ensure that it has gone through UL testing, right? We're going to get FM approval this year, I'm pretty sure. We'll be waiting for that for a long time. And the clean agents being used, obviously UL FM. So that's another reason why we're offering stainless steel cylinders, is to prevent any accidental discharge. I think it was mentioned by View, certain times when you put a cylinder in, let's say, the offshore environment or oil and gas or within the elements, there will be galvanic corrosion. If you know that there's dissimilar metal, so meaning carbon steel and brass technically don't go well together. So over time, as brass is a more noble metal, it will start to eat as chip away at the carbon steel, right? Another factor being that could cause an accidental discharge is that carbon steel is only protected by a layer of paint. So when that layer of paint is brushed off or dented or scratched, within the carbon steel, rust will start happening. That's why we are moving towards a stainless steel cylinder with a stainless steel valve. So if there is a scratch on the cylinder for the protective paint, there is a passive protection which will make it harder. That is one of the unique qualities of stainless steel, right? And when it comes to dissimilar metals, stainless steel together, there will not be any issues there.
Okay, thank you, Jacob. So we have another question. I will help Mr. Jacob answer here. I'm not sure about the thing, but it's going like if the system is default, do we need to replace the whole system? Okay, so it depends. So usually if it's our system, you can send us back to us and we will be conducting the test to check whether the cylinders has defaulty or of the cylinder, or is it the valve. So we don't need to change the whole system, right? But if but we do not guarantee of others brands system, okay, because our system might not be compatible to other brands. Okay.
I think another question here is how to determine to use HFC 227 or FK512 and the different pressures involved. Okay, my opinion is that number one, you have to look at what the consultant specifications are asking for. So some consultants are actually asking for, they'll either be blunt and say, look, I'm looking for a Novex system. I'm looking, this system has to be an FK512 system. Then you know that you have to choose an FK512 for this system. But if they are more, how do I say, not so direct, they'll give you certain hints, like they say, oh, ODP has to be a certain range, GWP has to be a certain range, the gas has to be released within 60 seconds, the gas has to be released within 10 seconds. Then you know, from there you can narrow down what type of clean agents they're asking for. Because if they're not so direct, then they'll give you these hints of which you have to read within the technical specifications. My opinion when it comes to whether it's 360 or 500 psi, it's always better to give the a little bit higher pressure because there's not much difference. It can flow further and faster through the pipework, and the cost implications are very, very minimal. We're talking very, very minimal. You know, a very small amount. When it comes to clean agents, which one do I rather use? Whether it's FK512 on a personal level or HFC. As a manufacturer, I would definitely prefer to use HFC 227. Although it's an older technology, you require less of it, it's cheaper, and if it's been used in asthma inhalers like Ventolin, it has to be safe, because how many people in the world have asthma and how many people use inhalers, right? So let me see. Another question, is room pressure testing a part of your scope? Yes, we do room pressure testing, otherwise known as room integrity test. Yes, we do offer room integrity test. This usually has to be done for us to actually seal out any holes or whether there's any leakages through the doors to ensure that the room can contain the clean agent within the time period required. So if there is leakages in the room and you don't put a safety factor there, it will not be enough to put out the fire.
Okay, so another question, if I give the order, how many days is required? Okay, so it depends on how huge is your order. Okay, so if of course if you that's 100 over room that we did before, then we need quite an amount of time. But if it's only one room or one cylinder, that kind of stuff, of course it can be like as close as 2 weeks or that kind of stuff. So yes, we'll see only from the amount of what you order. Please advise what is the minimum room area to provide the clean agent protection in the electrical enclosure. Will you take this, Jacob?
Sorry?
Advise if there's a minimum room area to provide the clean agent protection in the electrical enclosure.
Yes, we actually have smaller systems which use tubing. So we use tubing instead of a detector. That is basically is known as a direct action or secondary action, where we use tubing as a detector to actually put out fires using HFC or FK within electrical cabinets, smaller enclosures. It can be used for, it's actually used for laboratory fume hoods as well.
How can I select the cylinder size of both gases? So as Mrs. Jacob explained already, you have to go through the calculation of the gas required for each room first because even though you're using a similar gas, the size of cylinders, right? But because these two gases has to be calculated specifically for each room. So meaning the fill in the gas of the cylinder might be different, so it has to be calculated individually, and then from that you choose the appropriate size of the cylinder following the gas required for each room. Okay, so
Wait, hang on. Okay, which piping to be used for the system, seamless or ERW? It doesn't matter, either one. Seamless or ERW, schedule 40 is fine. According to NFPA, no issue. There's another question, how to eliminate the leaking of the cylinder, because most of our cylinder, we experience leaking every 6 months or 1 year. I think you actually have to find out from your manufacturer whether it's under DLP, whether it's under the defects liability period for you to actually replace. But if it's leaking every 6 months or 1 year, I think there's a huge issue. I don't know whether it is a reputable manufacturer or not. Within this, okay, another thing I think I forgot to actually point out, which was very, very important, is that you have to look at the approvals carefully, especially when it comes to UL approvals for the gas itself. Okay, some gases provided, I'm not going to say from which country or from, they have not undergone class A or class B fire test. So basically I can create a company, I go to another company, buy their UL listed gas and ask them to test it for the purity, and I get my approval. But you have to look at the approvals carefully, whether they have undergone class A or class B fire testing at all. So if you look carefully, if there is no concentration stated there, or they put an A with an asterisk within the UL product IQ website, you know that they have not gone through any class A or class B fire test. So it is quite dangerous. So ensure and look through the approvals properly. Also ensure that you check, especially for this person's question, is leaking every 6 months or 1 year, you check on the manufacturer, check the serial number, and see whether it is actually an approved system or not. Okay, there are, like I mentioned, there are some Frankenstein systems whereby I buy my cylinder from here, I buy my valve from this company, I buy my latching solenoid from this company, and I piece it together. I fill gas from some unknown place that has not been approved in a non-approved UL listed facility, and then they sell it to you. Yes, it's cheaper, but if someone dies, then it's not very cheap at all. Yeah.
okay, guys, may I remind you again, if you have questions, please send the chat directly to Miss Erica, because I have more than 30 questions flooding to me, and because I would like Miss Erica, the admin, to help us get the question right now, because I might not be able to see every answers here. Okay, please send directly to Miss Erica, because it's only flooding into me and it might not be answered. Okay, so some of the question that I get is, okay, why cylinders still burst? Okay, I mentioned of something that the cylinder may burst because of the high working pressure as an innergen system that I mentioned before, because sometimes the inexperienced workers doing the maintenance, right, it's have to be very, very careful that maybe it bursts. Some maintenance cost is too long, and the worker is not experienced, and a cylinder malfunction, and because of the high working pressure, the cylinder may burst. Okay, so can we adjust the gas releasing timing? Yes, we can. At the control panel, you can choose the timing. You can set to choose your timing there. Okay.
Okay, let me see. Let me see some other questions that we can ask. Oh wow, there's so many. Oh my goodness.
Yeah, there's a lot of question, guys. Sorry, because it's really
Okay, this
funny.
one. Okay. Okay. Do I recommend? Can you use Teflon tape for threaded pipes? Yes, you can. The museum one. Okay, let me see. What's the price comparison to other leading manufacturers such as Kitty? Do you manufacture also the equipment? No, we do not manufacture the room integrity test kit. We're open with that. What is the price comparison to other leading manufacturers such as Kitty? So I would like to say that what they have, we have. What we have, they don't have. We know that Kitty is a big product, but at Deluge here, we're definitely smaller than them, but we're more agile and we're more focused on R&D. So when it comes to the stainless steel cylinders, stainless steel valves, you can go check the website. I do not think that they have it at all. We are many years ahead of them. Price comparison wise, we are very, very competitive. Based on the experience that we've gone through, all the quotations, all the tenders and stuff like that, we know our competitors' pricing. We price our products based on our quality and being able to meet delivery as well. So yeah.
Okay, so as per manufacturer recommendation, if gas purging fan is required / mandatory to provide within clean agent room protection, please advise. So okay, I already explained that usually those high working pressure or in the gas system, there will be a requirement of a pressure relief damper because of the high working pressure. However, our system is low working pressure, right? So we do not require to install the pressure relief damper, but it is still up to the client if they still want it, but it does not required because we are low working pressure. It does not expand the pressure in the room, and therefore we do not need pressure relief damper. Okay.
I think this is quite a big topic, whether it's the silent nozzles or whether there's the requirement for the pressure relief dampers. These are the questions that we always get from consultants a lot of times. Yeah, just to touch on with what you said, as a manufacturer, we do not advise requiring pressure relief dampers. We do not encourage any of our distributors or any of the projects that we have actually installed to have pressure relief dampers at all. Okay. Another question, is it better to design a clean agent suppression system as one system per room or a centralized, basically a selective valve system? What we usually recommend is one system per room rather than a selective valve system. This is basically, if you have is basically saying that, you know, look, I've got two different things that I need to kill, but I only have one bullet. We'd rather have a coverage for every protected room required rather than a selective valve system. The cost implications based on what we have calculated and based through all the quotations that we have done, it is only, sometimes it can be cheaper, sometimes it's the same price. Most of the time, it is about the same price as a selective valve system, and yet I can protect every room there. Selective valve system is the largest room being protected, that's all. And you only have one bullet. So what we recommend is, it is always better to design an individual system for each room. Your piping will be much cheaper as well, rather than a long piping through a centralized storage system. The issue of low pressure every 6 months or 1 year. Okay, so it is, I'm not going to say the brand, which is mentioned here. It is the F brand cylinder, and we face low pressure switch with O-ring. Can you elaborate? Okay, sometimes the so I think the leakages is probably from the valve or the O-ring being provided. So this F brand, we know them very well. You have to, I think if it's for every cylinder that they offer you, I think maybe it's best to find an alternative really, because the damage is not only financial, it's your reputational damage that look to the end customer you're providing, you're always causing these type of issues. I think maybe it's best for you to find an alternative. But I think the issue is most likely from the valve and either the O-ring that is not sealing up properly. Yeah. Okay, I think are there no questions for you?
Yeah, okay, there's a lot actually. Okay, just we'll try as much as possible. We only have 5 minutes here. So if there are any questions left unanswered, I'll repeat again that there will be a survey form issued to you in the email at the end of this webinar. So you can type in your questions in the survey form, and at the end of the survey form we'll be providing the slides of today's presentation as well. Okay.
Another thing I would like to touch on, obviously Deluge being a Singapore headquartered company, we are very interested in getting into contact with other Singaporean companies as well in Singapore. We noticed during the registration there are quite a number of companies that we like to reach out and try to network through there. If you're keen, please contact us so that potentially we can have some sort of synergy to work together. We have some other consultants here that we don't mind going out to speak to them. Obviously, we have spoken to certain consultants from Arab and Savannah Jurong. I think the other consultants in this webinar that we would like to get in touch to actually meet them as well. I think it's almost 4 of you. I think maybe we would hand it over back to James, and then when it comes to the questions, we will try to consolidate and try to answer through the survey form. Is that right, View?
Yeah, so okay, unfortunately we have come to run out of time. So okay, I repeat again, for those questions unanswered, there will be a survey form sending to you through emails to give us the feedback and questions about this webinar, right? As well as the slides once you completed the survey form, okay? So if you feel there is a synergy between your company and Deluge, please feel free to reach out to us so we can discuss further, okay? We'll go back and see all of your question here left in our chat as well. Thank you all participants for your time to be here with us. Today, we hope we have a very good response in the number of participants here, and we hope that you all find this webinar useful. And thank you, PSME Singapore chapter, for the opportunity for my team to be here today. Back to you, Mr. James.
Okay, this is Richard, the Vice President of PSME. In behalf of PSME Singapore chapter, I would like to thank Deluge Fire Protection Private Limited, especially Erica, View, and Jacob for a very nice presentation of their company product and solution. Big thanks to Engineer James Abarca and Engineer Mon Dakanay for arranging this webinar. I hope that Deluge can continue to support our group for future seminars. I would like to acknowledge the presence of the members of the Philippine Integrated Protection Organization and the Philippine Mechanical Design and Fabrication Group. I hope the webinar had given you enough knowledge to understand better the clean agent system for fire protection. If you have any further queries or questions, you may send email to Jacob and View. Maybe View, Jacob, you can send us your calling cards, name cards.
Yes, so again, there will be an email sending out to all the participants here in this event, right? For the portal to contact us and give us feedback and actually to acquire the slides of today's presentation.
Okay.
And one more thing, Jacob.
Yes.
Usually our chapter, we are doing a factory visit.
Okay.
So later on, maybe when this CB is out, one of the months, this coming months,
Yes.
our group can arrange a factory visit to your plant.
That would be good. Yes, we will definitely welcome that. We'll probably have to have a name list and the number of participants so we can actually cater to your visit over here.
Okay, thank you.
Thank you.
Sir Richard, noted, yeah, sir.
Okay, thank you, engineers, for participating in the webinar. Enjoy the long weekend and advance Hari Raya to all. Keep safe, everyone.
Thank you. Stay safe.
Thank you.
Thank you.
Thank you all. Thank you. I'll be ending the webinar now. Thank you.